All right, so I'm going to change gears a little bit. Again, can you comment on the contribution of research in statistical natural language processing to linguistics? And that's a yes/no question, I realize, but okay.
One of the early proponents of it, maybe the earliest, in 1955, when I was working on linguistic theory, it seemed to me that the only possible way in which let's say a child could identify words in continuous text. You know, you're not hearing single words when you live in the world. You're hearing continuous text. It seemed to me the only way that could be done was by detecting transitional probabilities of sounds or syllables. That, you know, if you get to a word boundary, the predictability of the next sound is lower than if you're inside a word, right? For obvious reasons. So if you check these transitional probabilities, it looked as if you ought to be able to detect words. That's probably the first proposal, maybe the first proposal in the literature. It turns out not to be accurate. Just in the last couple of years, there's been some really careful work on statistical analysis of texts. Charles Yang, who got his PhD at MIT, is now at Penn, a computational linguist, cognitive scientist. He showed that if you actually use this technique on connected text, what you get is syllables, not words. So that doesn't work. He also pointed out that if you add a linguistic principle, you do get a better approximation to words. The linguistic principle is that a word, well, real words tend to have a stress peak within them, stress pitch peak inside them. So if you add that principle and then you do the statistical analysis, you get a better approximation. There's subsequent work by a number of cognitive scientists which have shown that if you add what are called the prosodic structure, the whole pitch stress structure of a sentence, you know, it goes up and down, really reflecting phrases pretty much. If you look at the pitch structure, if you add all of that, and then you do the statistical analysis, you get an even better approximation. This is one of the very few cases where there's any results from statistical analysis. There's a kind of a industry in computational cognitive science and computer science trying to show that you can get significant knowledge of a language by statistical analysis of texts. Antecedently, that's extremely unlikely to succeed. You do not get discoveries in the sciences by taking huge amounts of data, throwing them into a computer, and doing statistical analysis of them. Try to think it through in the history of the sciences. It just doesn't happen. That's not the way you understand things. You have to have theoretical insights. You have to know what kind of experiments to carry out, what kind of data are worth looking at, which kind you throw away, and so on. That's the way the sciences have always worked. If you want to, say, study the laws of motion, you could take a huge number of videotapes of what's happening outside the window and subject them to statistical analysis, and you could get a pretty good prediction of the next thing that's going to happen outside the window. Actually, a better prediction than what the physics department can give. But it's not science. It's a way of matching data and maybe predicting some new data. But that's not what understanding is. And it's very unlikely to work for language either. And I think the record shows that it really fails totally. I could run through examples. But every example that's been carefully studied, it simply doesn't work for pretty much the reasons that Charles Yang and his successors discovered. You have to understand the principles that determine what underlies the system, and then if you look around the edges of those principles, you can find some sometimes useful statistical data. I think that's probably the way it's going to continue, but certainly is the way it has so far.